Welcome back, stargazers. Today, we're tackling a fascinating question. Where does Earth's atmosphere end? And where does space start? Let's dive into the different layers that make up our atmosphere and see how they transition into the vastness of space. First up, let's talk about the Kármán Line. Located about 100 kilometers, or 62 miles, above sea level, this is the most commonly accepted boundary between Earth's atmosphere and outer space. Named after physicist Theodore von Kármán, this line represents the altitude where the atmosphere becomes too thin to support conventional aircraft. Above this line, aircraft would need to travel at orbital velocity to stay aloft. Moving higher, we reach the thermosphere. This layer extends up to about 600 kilometers, or 373 miles, above Earth. The thermosphere is characterized by its high temperatures, which can soar to over 2,500 degrees Celsius, or 4,500 degrees Fahrenheit. Despite these high temperatures, the air is extremely thin, and particles are widely spaced out. This is also where the International Space Station orbits, as the thin atmosphere here presents minimal drag on the spacecraft. Next, we have the exosphere, the outermost layer of Earth's atmosphere. It stretches from around 600 kilometers up to about 10,000 kilometers, or 6,200 miles. In the exosphere, the atmosphere is so thin that particles can travel hundreds of kilometers without colliding with each other. Here, the atmosphere gradually merges with the vacuum of space. This transition zone is where many satellites orbit and where the density of particles becomes negligible. Finally, let's talk about the geocorona. This is the most tenuous part of Earth's atmosphere, extending well beyond the exosphere. Composed mainly of hydrogen atoms, the geocorona stretches out to about 630,000 kilometers, or 400,000 miles, from Earth. The geocorona is incredibly diffuse, and while it's almost indistinguishable from the vacuum of space, it's still considered part of Earth's atmosphere. It interacts with solar radiation and can be detected through ultraviolet light. So, where does Earth's atmosphere end and space begin? It's a bit of a gradient rather than a clear-cut boundary. The Kármán Line provides a practical reference, but the thermosphere, exosphere, and geocorona all play a role in this transition. I hope you enjoyed this exploration of our atmospheric boundaries. If you did, give this video a thumbs up, share it with your friends, and don't forget to subscribe for more cosmic content. Until next time, keep looking up at the wonders above, stargazers.